my friends, and welcome to another episode of the AI Show. This is Seth coming to you from my very lovely house. All the drawings behind me, obviously self-made. Had a lot of time off. Well, not time off. Time at home with the pandemic. How's it going, everybody? Hopefully everyone can hear me. Where's everybody coming from today? It appears Sharafuddin has injured himself. Hope you're okay, buddy. I wonder what he did to himself. You know how when we basically get old and then you get like a back injury or something? Back when you're like young, how'd you get that back injury? Oh, I was motorcycling. Now it's like, hey, Seth, how'd you get your back injury? I stood up the other day. Yeah, that's what getting old looks like. Hello, Jay McCormick. I see you there. Ivana is here. J Star. Hold on. J Star. Trying to get a little action there. Where's everybody coming from? Just hit me up in the chat. Tell me where you're coming from. I'm excited to be here. Today we've got some cool stuff. So let's talk about that right now. Let me go to my screen here and then use this wonderful device. Today, let me alt-tab here to get all the info that I need. Gosh, I'm so old nowadays. You know what I'm saying? I just don't even remember what's going on. Okay. Number one for today, NLP. Verseagility. Boom! That's a cool name with Timm. Very excited to have him. He has been very gracious and said he would stay afterwards to answer any questions you might have. NLP task with Verseagility. It's pretty cool. DF Meta. Buenos días. Bienvenido. Hold on. Bienvenido a Viernes Gigante. Sorry, there's a show if you're Hispanic or Latin. Sábado Gigante. What was his name? Don. I don't remember his name. Don something. Welcome. Number two today, of course, rock, paper, scissors. But this time, I think we figured it out. I think we'll be able to get to the part where we get the best model size versus accuracy. We're going to do that. Oh, Ivana. Viernes Gigante o Picante? Viernes Picante! That sounded better. I think that sounded better. Pretty excited about that. So we're going to get the best accuracy, and I promised, I didn't, I like keep using AML, Azure ML, and I'm really not showing people like what it is. I'm so bad at this. Viernes Picante. So I thought I'd show you what's going on. You kind of, I don't know. I'm not here to hawk our wares. But if you have any questions about it, I'm happy to answer them as well. So that's what we're doing. And then maybe we'll get back to our React app if there's time. Again, hopefully everyone is having a Don Francisco, that's right. DF Meta, Don Francisco. That's the guy. Oh, jeez. Don Francisco is right. I remember, I don't know why we watched it. I think he was in Florida or something. Don Francisco. Oh my gosh, that guy. So that's what we're doing today. Hopefully, we'll get some success. We don't always get everything to work, but you know what? Neither does every other dev/technical person. You know what I'm saying? It's just sometimes it just doesn't happen. That's okay. Today we're gonna make it happen. I'm pretty excited about that. So those are the things that we've got. We're ahead of schedule. So why don't I just bring Timm in here so he can. Hey, Timm.
Hi, Seth. How's it going?
Fantastic. So I found out today, and I feel horrible. We'll get serious when we do the show. Timm is in Germany. I am ruining a perfectly good Friday night for Timm. Oh my goodness.
It's quality time. No worries.
Quality time. Oh, Timm, we got to show him the way of what quality time is. The reason why I do this show on a Friday between 11 and 1 is because by the time we get to a Friday as technical people, Timm, you'll appreciate this.
Yeah, totally. And it's quite early in the evening.
Yeah. We're so tired that if you just want to watch something and maybe relax at work, you could just tell your boss, hey, I'm watching a Microsoft show. And then they're like, oh, okay. So it's actual work. But we really just hang out and do stuff. Timm, dude, thanks so much for being with us, buddy.
Yeah, thanks for having me today.
All right. So a couple of things. Just let's make sure your screen is working. It is. Look at that gloriousness.
Totally.
Good job. Couple of things I always tell the guests. This is like a live studio audience. So they're really cool. We won't take questions from them during the show. A couple of rules. Just look straight at the camera. I'm gonna turn this music off because I'm not allowed to have it on there. Any questions for me, bud?
From my side? No, I'm fine.
He's like, I got this.
We can get started so far.
So good. You got this.
Hopefully.
Oh yeah, and the other thing is look at the camera when you're talking. If you look away, I'll switch over to your screen. Wonderful. Okay. All right, buddy. You ready?
I'm ready.
I'm going to do a little intro. You're not going to want to miss this episode of the show where Timm tells us how to ramp up our custom NLP tasks with Verseagility. Make sure you tune in, and then I'll do, and then we'll get into it. Okay. And I always mess up. Like the studio audience is going to be like, I always say stuff like, if don't say stuff like, can we do that part over again? Because then we have to. But I'm the one who always messes up. So, all right, Timm, you ready?
I'm ready. Let's get it.
All right. Here we go. Okay. You're not going to miss this episode of the AI Show where Timm tells us how to ramp up our custom NLP tasks with Verseagility. Make sure you tune in. Hello and welcome to this episode of the AI Show. We've got a special guest, Timm, to talk all about how to ramp up your custom NLP tasks with Verseagility. Timm, tell us who you are and what you do, my friend.
Hi, Seth. Thanks for having me today. My name is Timm. I'm a delivery data scientist at Microsoft based out of Germany. And what I do here is I work together with our strategic enterprise customers with focus on NLP tasks and solutions that end up being in production.
This is awesome. So a bona fide, real data scientist, not like me, that plays it on TV. I'm super excited. Tell us a little bit about Verseagility. What is it? How can people use it? Let's get started with Verseagility.
Yeah, let's get started, definitely. To give a quick intro about Verseagility, this is a toolkit you can see here on the screen. It's a GitHub project. So my colleagues and I, we faced the situation that we're doing things over and over again, the same things somehow, especially when tackling NLP tasks. And that is once we get on a project, for example, and we want to provide some classification models, we always spend quite a lot of time setting up our infrastructure and get things going, set up our experiments, like you can see here in that image. So it always takes a while until you actually can get to the fun part, and that is building models for NLP tasks. And then we also thought most likely that's not only the case for us, so also for our customers and people out there as well, so developers who just enjoy tackling NLP tasks. That is why we took our time to build kind of a toolkit that saves you time and helps you to focus on the actual NLP task.
That's really cool. So basically, you kept running into, because every project, I feel like in machine learning or any project in general, whenever you start a new project, you do file new, there's a whole bunch of things that you have to set up. Basically, this is intended to make it a lot easier to make these kinds of NLP tasks a project. Is that correct?
On point, exactly.
All right. So what does it actually consist of? What are all the goodies that you put in there?
Happy to give you an intro there. So once again, what you can see in that illustration is kind of illustrating the process, how you usually go in NLP tasks. So you always have, you finally get your data, or you find your data, or you collect your data, then you always have to set up environments, your pipelines, then finally some experiments, you prepare your data, then usually NLP tasks can be quite messy, so you have to do some data cleansing. Finally, you get to the model training, and then you already have to bring it into production, so make a deployment. And then the iteration starts, and then you usually don't have time anymore. So what the toolkit consists of essentially is a component for all of these things. So what we bring is a standardized template, which you can deploy to Azure. So get going with infrastructure as code. That's the first thing. Secondly, you can get scripts that help you to solve your NLP tasks. So for a separate script for a different task, but you can start it with a central wrapper. And last but not least, you get project configs. So that you can, let's say, document your task in a central structure and also versionize that as needed.
That's cool. So it's basically everything you need to follow this process that we're seeing here on the screen, which is a standard NLP process.
Exactly. Or any data science process, how you want to have it.
Yeah, that makes sense. So it feels like you've told us a lot about it. Can you show us how it works?
Yeah, sure, of course. Quickly, so the tasks we're going to cover for now, which are supported by the NLP toolkit, are binary, multi-class and multi-label classification, named entity recognition, and question answering. And that's what we're going to dive into now. So you have the repository here, and your requirements here. So of course, that's what you need as well. And what you find here in the source folder are, let's say, all the components that somehow, let's say, when you build them together, make the use cases at the end of the day. So I would say let's jump into VS Code. So what do you usually do here? You start over with a project file. So for example, you want to do a project for Microsoft Forum data. That's the config file here. And that's a config file you can prepare as needed. So for example, if I want to bring some data and I want to do classification and the others, I don't need them at the moment, for example, I just remove it. And then you can go in with that. What we also support, for example, is here you have different environments, so dev environment and prod environment, because that's relevant at a project. And that's your central config file where you start your project.
Sorry to interrupt. I want to ask a couple of questions. That's okay. First, can you press Control Plus a couple of times to make that a little bigger for my old eyes here? And then the other question is basically this config specifies the kind of NLP task that you want to do. Am I getting this right?
Correct. Exactly. Yes.
Okay. And it goes all the way from the thing that you want to do, which is the tasks, where the data is, what kind of data type it is, and then where you want to deploy it. So it goes from the actual beginning to the end. Is this right?
Yeah, so basically that's a starting point, and this config file is essentially going to control the script once you run it. So this is essentially what we recommend doing in the beginning, and of course, going from the repository, you want to set up your infrastructure as well. So when we go to the Azure portal quickly, so when you're in the documentation of Verseagility, you click on the deployment for the ARM template, which you find in documentation, and then you have these resources here, and all of them are automatically going to be deployed to your Azure subscription. So you don't have any efforts in setting up the infrastructure. So then you have both components. You get the code from GitHub, you deploy the code to the infrastructure components to your Azure subscription, and then essentially you have almost everything you need. And of course, you have to bring some data. Very important.
Of course. I mean, so let's go back to the config file, because I have a couple of questions about maybe the data. Like when you say the data, does the data have to be in a specific shape, or is there anything you have to do for that?
Exactly. So we have a standard file format for Verseagility, which we defined, which is going to be, let's say, collected by a backend service, which is part of the template. Because one important thing is definitely we don't only support normal text files like a CSV file. Rather, we also do document classification and email classification. So sometimes when you bring a bunch of emails, you drop them into a pipeline, and yeah, there is actually a lot of valuable content in these emails. So often you have documents from customers just like, hey, please find attached, best regards. So that's not very valuable. So you're going to find that in the attachment, and that's what we have to consider as well. If you just have a CSV file, for example, and you want to do classification and NER, you can transform that also with a notebook which we prepared for you. So just load your data set, and you can use the notebook to bring it into the right shape.
I see. So basically, if you have your data, there's some notebooks that you provided that will shape the data in the way that Verseagility wants.
Exactly.
Okay.
Correct. Yes.
That's cool. All right. So how do you run all of this? So the first thing I want to, and let's show our faces so people can see me asking. So the first thing I want to ask is, basically you have to run the ARM templates to get the infrastructure. Then you have to prepare the data. If it's already in the right shape, that's great. Otherwise, you use the notebooks to shape it in the right way. You describe the actual tasks /tasks you want to do. And once you do that, how do you actually run it?
Okay, so of course, what you need to do is, first of all, make sure you have all the requirements set. That's why we have a requirements txt, and most likely you also have to log on to your Azure subscription using the Azure CLI. So what we have here, we already have the virtual environment started. So all the dependencies are already loaded. So we can get started. What we're going to do now is, as you see here in the source folder, we have all the tasks here, which we need, or all the skills, for example. And how you're going to trigger it is you're going to find these scripts in the deploy folder. So there is a training script, which we're going to open quickly and have a glance at it together. So of course, first of all, we're going to load quite a lot of dependencies from Azure ML, because that's where what Verseagility is built on as well. So we leverage the Microsoft ecosystem here. We are going to load some parameters which you can bring. So for example, your project name, of course, then a compute name if you have multiple computes, so remote power on Azure. And then you can also say whether you want to do data preparation. So usually we first have to prepare the data and then submit the training to a remote compute.
Got it.
Exactly. Here you can see how your config is going to be loaded. So the central component of the toolkit. And then you get going by loading your workspace. That can either be, if you work locally, with a config file, or also enterprise readiness with a service principal, for example.
Got it.
That's how you can see it here. So first of all, if you say you want to do data preparation, we go into this section here. Then a preparation task is going to be executed. If that's finished, so we have the entry script for the preparation here. Once the preparation is done, the prepared data set is going to be registered and available for training. And if you activate training, you're going to go into this step here, where the training happens, where you also pass your parameters you want to have for the model.
Okay, so as I'm looking at this, I want to be sure that this is basically a really fast way to bootstrap enterprise-grade machine learning processes, specifically with NLP. Now we talked about the data, we talked about the infrastructure, we talked about the bootstrapping and the running of it. Now I'm curious about the actual machine learning that's happening. Did you write your own custom machine learning models or using other frameworks together?
Yeah, of course, we always want to use the latest of the greatest, who also other data scientists love. So, of course, we reuse a lot of things that are out there. So let's quickly go back to GitHub because there it's a bit more visual. So here's basically our tech stack. So we have at the bottom, we have AML, we have Kubernetes for deployment, we have Docker, and of course Python. And then in that area here, that's where it's going to be, or that's where it gets interesting. We support different frameworks that data scientists, especially focusing on NLP, really love. To get started here quickly, Flare and Spacey, great frameworks for named entity recognition. We have Gensim here for especially for topic modeling or also question answering based on Best Match 25. And then we have these two components here. So transformers, so pre-trained models based on PyTorch. So quite big models that help you to accelerate your NLP task, and available in different languages. So yeah, Hugging Face Transformers is definitely a place to stop by if you want to have pre-trained models.
This is
And,
cool.
yep.
So basically, you've built the entire infrastructure together with state-of-the-art NLP frameworks and put them together in a sensible way to get a reproducible kind of. And now I feel like I need to say ML Ops. You basically created a template for ML Ops to do NLP work on Azure ML. Do I get that right?
Essentially, yes. So the cool thing is that we generally support also retraining. So there is no full MLOps process, let's say, built in Verseagility, but we also allow retraining as we also have a Cosmos DB in our ecosystem. So, for example, if you have it in production and you do some relabeling, they're going to be sent back to the Cosmos DB again. And for example, in your next training round, you have more data and you can have that again. So this is basically your template to get started. Not a full ops process, but definitely extendable and supports different loops.
That's really cool. So can you give me a sense? And I know we usually don't talk about the customers the stuff that they do, but can you give us a sense of what people can do with this kind of actual real world applications?
Totally, yes. That's where it also comes from, of course. So we kind of saw a pattern working together with our customers that, especially in the support unit of the customers, they are flooded by support tickets, incoming emails, and things like that. And it's hard to cope with that. So you need a lot of manpower. It takes a lot of time to respond to these emails. And of course, there are also customers who get frustrated at the other side because they wait for a response. So our customers often talk to us like, hey, we need to automatize this so that we at least can cover the, let's say, simple cases and build kind of an automation behind it. And yeah, for the most part, there are user-generated content like support tickets or emails, and that's a typical setup. And some of our customers, they want to have it integrated in their email system, for example. We also have customers who want to have that integrated with their dynamic system, so more CRM, and also just have it as a REST API that a service can call it. So that's what makes it flexible.
This is cool. So basically, any place where you have free-form text, you could superimpose intelligence, and you already have data everywhere to be able to do this kind of training.
Exactly. Yes.
Well, this is
And
awesome. Anything else to add, my friend?
no, that's it so far.
So this has been really cool. Where can people go to find out more?
So there are different things that you can try. So of course, make sure you go to GitHub. It's a public repository. Make sure you check it out. You can also even try it locally if you don't have an Azure subscription. So we don't want to limit it to cloud applications. So that's, let's say, the central component. And another thing is, yeah, we linked all the other frameworks we support here as well. So make sure you check them out as well. We are very grateful that there are many people out there working on such great things, which we then can just reuse in a as a model in our toolkit. And then also, if you want to check it out, how it looks like in action, you can go to the demo here and yeah, try it out how it looks like a bit.
Well, let's
If
see
it's
what
in
it does.
action.
I'm interested. Can you control plus a couple of times, and then let's see what this looks like in action?
Yes, let's do that. So yeah, just have an example or some example tickets for you. How you can, let's say, use it as an API. So we built a very simple front end here based on Streamlit. Make sure you check out Streamlit. It's a great framework to build data science demos. And yeah, if we click submit here, for example, for this support ticket, so we use typical support tickets that might occur in the real world. So there's a person having a problem with his Windows, for example, and maybe he has a virus, and yeah, he or she wants to speak to Bill Gates maybe to get some help. So what you see here is the classification. So that's basically what comes back from the service. And we clearly classify this here as a protect, so Microsoft Protect, anything like antivirus or a Defender, something like that. If we scroll down, we also extract entities and highlight that here a bit. So we see we can somehow extract information like error codes or customer numbers, and that's where a lot of value comes into play, especially for our customers if they want to automatize, so enrich their support tickets with information we extract from an email. And also what we have here that is based on a ranking algorithm, best match 25, where like historic tickets that might have helped to solve a case get automatically recommended. So the subject matter expert working in the support unit can just say, okay, we had something like that in the past as well. I can just reuse that email, and you get much faster replying the request of your customer. So yeah, we can try one more maybe.
Let's do it.
What's doing here? Another example. Okay, so here we have once again, no, let's take another one, not only protect. We don't always have virus problems.
Here we go.
Surface, fantastic. So yeah, there is someone having problem with his Surface, a great device. So yeah, switching to the front camera. So once again, with the classification, looks good. Also very high confidence score. That's nice. Some entities extracted and some answers that, yeah, might have helped to solve the problem. Another cool thing is it's multi-language, so it's also a great thing about Verseagility. We don't always do things in English, especially I work a lot with German customers, so they want to have it in German as well. So can try that out as well.
Let's do it. Das ist unglaublich.
Yeah, very good. Das ist unglaublich.
That's the only German I know. That's what it looks like.
All right, so here we, once again, yeah, Defender, they always have security problems. So Defender is deactivated. Hallo Leute, ich habe jetzt alles versucht, jetzt bin ich am Ende. So this customer has real problems here. So yeah, even gives an error code, which always helps. And it's also recognized as an error code, which is great.
That's cool.
So yeah, we can definitely work with that. Great, jetzt, so now that's the daytime, so I want to have it now. He needs urgent help. Okay, if we scroll down a bit, you also see one more thing here. That's a JSON result, and that might be very interesting for developers. So that's when you build the API with Verseagility, this is what you're going to see here. So so you send a request to a REST API, which we can also have a look at again on a notebook, for example. And this is what you get back. So for every task you have, so task 1, classification, you have the result here. So in that case, protect with a high confidence score. Then for task 3, NER, with a list of results, also where it comes from. So the most part comes from Spacey in that case. We also support text analytics here, which is also a great cognitive service you can use on Azure, and also the historic answers. So that's how it looks like in the raw format.
Wow, this is really cool because it's basically like a cognitive service. Well, you've integrated cognitive service, but it's like a cognitive services that's trained on your specific task, your specific problem, if you're using Verseagility. Is that right?
Correct, yeah. If you want to have it that way, it's also an API at the end of the day, and you can have it custom made. If you do it for a customer, for example, it's really with their specific domain. So in different kind of domains and use cases, you might have different vocabulary, which are sometimes not fully supported by a pre-built service like cognitive service, but this is really how you can make it completely custom. Yeah.
This is really cool. Well, Timm, thanks so much. Make sure everyone, if you want to check it out, go to github.com/Microsoft/Verseagility. Thank you so much, Timm, for being with us. And thank you so much for watching. We're learning all about ramping up your custom NLP tasks with Verseagility. Thank you so much for watching, and hopefully we'll see you next time. Take care. Timm, you're a pro, man. There's so many questions. Timm was
really
like gracious, and he's like, I'll stay and answer questions. All right, so let's get some questions here. First of all, people love your shirt. Oh, Parasher. I know him.
Hi, Parasha.
Good dude. Here is Martin AK is saying this is super cool. I think so. I think it's cool. Here's Sharafuddin. Building NLP solutions would cover all components of text classification, named entity recognition to answer the question. This is cool. Require testing and integration effort, and you're saying that this Verseagility helps you ramp up that whole process. Is that right?
I think at the end of the day, it's all about getting first results. So your first solution is never going to be the perfect one. So you need some iterations. So you start with your task. You see, okay, the performance not so good. You do some integration testing and see how much value you get. If you, for example, do batch scoring, or you already integrated with your application. So that depends. So of course not. If that would be great if you just give the data in and then the perfect service is going to come out. But then it would be boring as well.
Oh, Timm, well said. You're right. And Janet Scoop, bringing it up in Twitch. Thank you for being with us, my friend. Sharafine also says, awesome toolkit. What languages are supported? And I guess since you're customizing it, you could basically make it use any language that you're putting in there, right?
Correct. So at the moment, we build it in a way that we support 5 languages, but it's completely language agnostic. So whatever language you want to support, you can just bring it. It's essentially a central config file where we link all the pre-trained models. So the transformer models. So at the moment, we have German, English, Portuguese, French, Spanish, and whatnot. And if you want to add further, of course, feel free to. You just have to bring some subword lists, for example, for data cleansing. And what we also have, which is really cool asset in Verseagility, to clean some typical email corpus. So you just have to bring some assets for your language code as well. And what else do you need? Yeah, pretty much it. Subword lists, some data cleaning, and connect it to the model you need on Hugging Face.
Awesome. So basically, since you're actually amalgamating a bunch of toolkits like Spacey, Hugging Face, etc., you just got to bring your own lunch, so to speak, when it comes to NLP tasks like stop words. Do you do stemming or anything, or does that happen inside the frameworks?
It depends for what task, actually. So for transformer models, we experience that they perform really good if you have, let's say, normal natural sentences, so really proper language. So that would be for classification in our setup at the moment. For NER, it depends, definitely. So we do some stemming. And where we definitely do stemming and lemmatization is for the question answering task. So the best match 25 to have a clean corpus there. And yeah, for all of them, we just do the noise removal, like salutations, best regards, mit freundlichen Grüßen, and so on.
Yeah, because those are nice words, but they're not information heavy words in the task, so to speak.
Rather a bit noise in that context. You're right.
So a couple of questions. Does Verseagility cost anything?
Verseagility is a free toolkit, so you can just get going and use it. You can get it on GitHub. So from that perspective, it's for free. We also only, or not only, but for the most part, use open source frameworks, where you have to pay a little bit if you deploy to Azure, so that you can leverage the full, let's say, enterprise readiness. And for example, if you leverage cognitive services, but the template is for free, and you can also just play around with it locally on VS Code, for example.
Got it. Another question. How do I process huge data like 100 gigabytes of data? Because the infrastructure is not handled by Verseagility, Is this a versatility problem or an infrastructure problem? Your thoughts?
Oh, that's a very good question and a very challenging one as well. So, first of all, we do have quite some power with us as we use Cosmos DB for our central data storage. But of course, you need a little bit power, so you need to scale up there, and then it costs a little bit more if you have it on Cosmos DB, for example. And how we usually process it, either we do some data, smaller data chunks before submitting big trainings, and if you really want to go hard with large data, then you of course need larger computes. But yeah, I will have to say I haven't tried it with 100 gigabytes. So feel free to do so and give me some feedback.
So here's a question, and you don't have to answer this. What's a typical size of data that you would need to make these tasks effective?
Of course, typical answer, it depends. So how many classes you have. So you can get really good results already if you bring, let's say, 1,000 documents in 8 or 10 classes, that you're definitely going to get solid results. Where it gets really fun if you have, let's say, 200,000 or 300,000 with 20 classes, for example, then you can really expect a solid performance. So the example I showed you for English, we have, I think, 8 classes and train it on 300,000 documents. And you also saw that even for the small corpus and a little bit additional, let's say, words you don't need for the context, performed really well, and the confidence score was also pretty good.
Yeah, there was no doubt in the examples that you put. It was at 0.98 or something, which was really cool. All right, so I think that's everything. You've got the A-OK from Jay. Really neat. For Jay, the scale is okay, and then really neat.
Oh, appreciate it.
Yeah,
Thank
I
you.
think that's it. Jay might have to correct me because I totally just made it up.
Okay.
Really neat is like is after okay. Neat. Sorry, it's okay. Really okay. Neat, and then really neat. So you're really good job, Tim, on that.
That's not bad. Thank you.
Awesome. All right, dude. Well, thanks so much for being with us. We'll see you next time, bud.
Have a good one. Thanks for having me.
All right, my friends. Tim's pretty cool. I feel bad we made him stay up. Like his Friday night. What time is it in Germany? Let's see. Current time in Germany. 8:38 p.m. He's definitely missing out on some Friday night stuff. Sorry, Tim. Sorry. Olga, this is really cool. Kudos, Tim. I thought it was cool too. 8:38 p.m. in Germany. That's right. Thank you for looking that up. Awesome. Alrighty. Verseagility. That was cool. Make sure you go to it. I have the link here just in case. GitHub.com/Verseagility. There was a question about Lewis. Sorry, I missed that one. DF meta. I don't know the answer to it. Alrighty. It's time to get to work. I gotta use that sometimes. Oh, I still got my radio announcer. We've got to use that because someone paid for it. Let's get to work. That sounded like let's get to twerk. I'm not gonna do that. It's lunchtime for some people, and clearly we don't want people to lose their lunch. Okay, a couple of things that I figured out. By the way, we are actually creating a classification. I'm a computer vision guy. On Twitter, I just take the computer off and say I'm a vision guy. You know, leader of thoughts. I can't bring myself to put on Twitter, thought leader. I think I should do it just like on April 1st. Just like that's my joke. I'm a machine AI thought leader. What does that even? What does a thought leader mean? Like, is there like a corral where you put thoughts into? I don't know. I'm gonna control plus this one more time so we can see. So basically, it's a convolutional neural network, and me and Jay were trying to figure out, like, we want to get good performance with a small model. The amount of data that we have, obvi, it's in here. So let's go to Reveal in File Explorer. Let's move it over here, Windows. Okay, let's not put it on this window where no one can see. This is the rock paper scissors data we've got. Oops, I want to see how much it is. Let's right click. Properties. Propiedades. We only got like 5 megabytes of pictures. It's not a lot. I mean, here's Seth. Here's Seth just sitting there. Look at him. What's going on here, Seth? What is going on here? We don't know. So these are just pictures of me in various states of paper, rock, and scissors. Here we go. Or rock, scissors, and halt. I would make a fantastic crossing guard. I could direct traffic powerfully in any country. So this is the data, and we're pushing it through these things. This is PyTorch with PyTorch Lightning as a framework. I like it because it helps me organize my stuff into the data. Notes that the data is coming out of the using an image folder, and it's using the folders to get the classes. So it's super nice. And then the model, which has the actual PyTorch Lightning PyTorch model. If you've ever done a PyTorch, this thing inherits from like the PyTorch module. I think it's called a module, and it has a init and a forward, and this is all you need. But PyTorch Lightning adds some extra beef, like training step, validation step, a way to configure the optimizers. We're using stochastic gradient descent with a stepped down learning rate. I don't think I need this. What are we doing here? I don't need this. Taking it out. And then also a little save component that saves the model to Onyx, plus some metadata. So if you run it, this is what you get out. It's like, here's the classes, here's the model, the param size. This is not helpful though. I should do 5 megabytes. Maybe there's some code to convert a number into MB and GB, etc. Or G, M and G. Okay. So that's where we are. And what we wanted to do is we wanted to run this a ton of times to see what is going on. Hello, Hadi. Welcome, my friend. And then also, I'm here to answer your questions as well. Okay. The trainer is a thing that marries these things together, the Roshambo model, the Roshambo data module, and then we just run it. I'm using ML Flow to do the logging. I'm doing an auto log, starting to run so that all of this lives in the same place. I messed this up before because I didn't do it in this context, with the context of this run. And so it was basically bifurcating the experiments, which was kind of dumb. So this should all be fixed. And then at the end, we're going to do model size. I wonder if I can... I wonder if there's some code here. Let's see. Python convert number. There's the size, mega, giga. Let's see. Maybe there's some code here. Converting B to KB. No. Human readable. Python, human readable large numbers. Doop. Doop. Oh, look at this. Human readable large numbers. Oh, wow. Oh. Millify. What is this? Magic. Format n over 10 to the 3 times mil IDX time. What the heck? Okay, so max between 0 and the min of the length of this minus 1. So 1, 2, 3, 4, 5. So 5 minus 4. The minimum, so 4. And then int math that floor 0 if n equals 0. Else math.log 10 absolute value of the number divided by 3. Oh, man, this is so clever. This is some clever crap. Sorry for my French. So basically, the logarithm of this number, specifically the base 10 log, will tell you the power with which you need to raise this number if you were to get out. So basically, divide the number by this, like 10 to the first, right, would basically be it's the tens. But looks like they don't do anything with tens. 10 to the mil IDX, 3 times mil IDX, because it's every one of them. Oh my gosh, this is... I don't know if I want to do that much math. I know it's super nerdy. There's got to be something better than that. Oh my gosh. Or I could just do this. I could just do this. Comma. Let's just put a comma. Oh, I know. It's basically... So the way I remember... nothing on hundreds or tens, yes. So basically, this is clever. I mean, so the way I understand powers... So math to me has it's like they're not enemies, but they're like frenemy computations. Like everyone knows plus and minus are frenemies. You know, times and divide, they're frenemies, right? Frenemies. The frenemy of the 2 power of something is the log of that something, right? So let's just say you have a number, right, and you're trying to power it. So 3 to the third, or 2, squared, or let's just do something easy. Let's do 2 to the third power is obvi 8, right? And so basically the way you count it is there's 2, right, and then there's 2, and then 2 more, and then let's see, 2. So 1, 2, and then 1 more. All right. So when you do this, basically it's like what you're doing is you're saying 2 once, twice, 3 times, and then you count these things at the end, right? And these things at the end tell you that value. So that's 8, right? So 2 to the third power is basically expanding a tree out for you. The logarithm measures the height of that tree, with the base of that logarithm being this number. Does that make sense? So the log base 2 of 8 is 3. I believe that deserved an air horn. Are you understanding what I'm saying? This is how I think of math things. There's like all operations have their opposites, right? Like for example, here's d by dx, and then you have the integral, right? These are also frenemies. It's how you do and undo things. So that's how I think of logarithms. And so when you're looking at this, basically what this is doing is it's taking the number. Where's the log stopping? Yeah, so the log is stopping right here. It's looking at the absolute value of this number, and it's saying, how many tens do we have to go down? How many breakups of that tree that's branching at 10 do we have to go down to get the count of that number? And that's what tells us how high the tree is. I don't know. I feel like we need a better, we need like a more logarithm. There you go. That felt better. There you go. So that's what's going on here. The problem with logarithms is if n equals 0, the log of 0, I think it's just 1, right? So that doesn't make sense. Because anything to the 0 power is 1. So there you go. More logarithm. Yeah. So that's what this is doing. And this is actually quite clever. But I think I'm just going to do this. I'm just going to do this. Okay. Because this, boop. I think I'm just going to do that because, yeah. Beep, beep, beep. I think I'm just going to do that. Oops, Control Z. Okay. I mean, I could do the other thing, but I feel like that's a little too highbrow, you know? I don't know. Anyways, hopefully that little mathy thing was helpful. I'm such a fan of math. We go way back. Way back. Way back. Fix my mic. All right, so let's run this thing. I think we've got enough. And we were going to try a bunch of different models. Let's make sure that McLeod stuff is good. Job, good. Everything's happy here. And then what we want to do is, let me split this to the right. Let's go to the model, and let's start where we're going to pick a bunch of different models. So let's do this small. Let's do a MobileNet V3 small to start, just to see if everything's going right. So we'll right click here. We'll create the resource. And we'll go back to this wonderful, wonderful thing that I use to, by the way, we don't need any of these. Let's see. Is it going? Is it trying to figure out if things, sometimes it gets mad at me. It gets mad at me sometimes. I'm going to restart it. Restart it. Have you tried turning it off and on again? No. So I uploaded all this data into like a cloud storage thing. And now, oh, we got to wait for things to load up. Here we go. You know, if I got to go to work today, you do too, Python extension. Azure. Okay. Looks like all of y'all need to get to work too. Let's get to work. Get to work. Here we go. All right. Now I can right click, create resource. Do your thing. Do your thing. Oh, why does it say this? It does too exist. By the way, I'm using like early bits of stuff, so this is not all the way done. No, it's not early bits, public preview. So it's not like everyone can use this stuff right now if they want to. They want to. Okay, so let's see what's going on over here. It's not started yet. Okay, here we go. Now it's checking to see if it exists. Okay, now it's going. Time to get to work. Here we go. It's loading up my job. Yeah, well, we're doing a MobileNet v3 small. And we're going to see if it's the right thing. There we go. Uploading. Let's go over here. See what we got. Uploading. We'll go to. It should pop up here and be like, I just started a job. Oh, here we are. Here we go. Any second. It's like when I take my kids in company, and it's like, don't embarrass the family. It's mad at me right now. I don't know why. Oh no, it's working. Oh, it's doing its thing. I just have to refresh. Refresh. There it is. I knew it was there the whole time. Oh, did I start it twice? When did this one happen? Run 22, September 3rd. Oh, that was last week. That's the last one we did. Let me delete this. Yes, because it doesn't make sense. I even capitalized it. No, I hit the wrong thing. Yes. Delete. Close. Let's go to this one. This one is running. Okay, we can see everything's in there. Wonderful. Let's change the let's change this. So let's edit the columns. We have accuracy, loss. Okay, we just got to make this thing run a little bit more. All right, let's see what it's doing. Outputs and law. Oh, it's running. It's doing its thing. Here we go. So basically, I'm running this machine learning deal in the cloud. Oh, it's just hard to see. Let me Control+. There you go. Is that better? One more for good measure. Oh, this is huge. Let me just go full screen. You can see it better. And Control. Oh, too much. Okay, that's good. Okay. At epoch 19, refresh. How is everybody doing, by the way? We just watched this machine learning thing happen. Do the thing. Yeah. I do have a pure evil laugh. It's scary. Even for me. I wake myself up at night with this scariness. You know? Okay. It's going. Evil laugh, I can deal with. Surly death. Oh, yes. There, the pen clicking. So one time I was on... One time. I get like this nervous tick. I don't even have my pen anywhere around me, so this doesn't happen. I was clicking on the pen. My wife took the pen away from me. FYI. Okay, let's go to the details here. See, stuff is happening. Let's go to metrics. Oh, wow. Look at that. We have accuracy. Oops. Accuracy. Validation accuracy. Look at that. It's getting to 1. Validation loss and loss. It's just hovering around this area, which is great. 3 minutes and counting. It's been running for 3 minutes. That's the thing about these things too, is they're not slow. Looks like it's on epoch 40. For those wondering why it keeps running, basically what I've done, and you can see it's running here too. Basically what I've done in the config is I've told it to continue running until the validation loss min delta is 10 to the minus 4 with a patience of 5. So basically, if the loss doesn't improve by at least 0.0001 5 times, it will stop. And so as long as it doesn't improve, or the loss continues to go down, it will just keep going. And by the way, this is the time where I'm running a bunch of experiments, and so feel free to like be like, "Hey, I don't know what this part of your code means, Seth," and I'm happy to explain it. It's like it's done. Okay, refresh. Perfect. Now look at that. Look at the little commas here. Model size and param size. That looks much better. Then let's go to the Roshambo here. I don't like what's in here, so let's change the columns. For us, this doesn't exist anymore. Remember, we tried to we had a little issue there. So we'll take this off, take this off, take this off. And what we'll do is we'll add, I think it was the model. Where are you? Mode. Where is it? Save. Let's save it here. I don't know why it's not letting me find model size and what model type. Model type. So let's put that in there. Well, hopefully it's there. Maybe it, oh, there it is. Model type, model size, and then param size. And then let's do this. Let's add a max. Let's do a validation, a val accuracy. So we'll do the max validation accuracy, and then loss, min loss. And let's also do that on the regular, on the training. So the max accuracy and the min loss. Okay. Let's save this here and refresh this. I don't know why it's doing it like this. I don't like that. Then the other thing we need to do is let's redo the charts here so that we can see them correctly. And then maybe what we'll do is we can take these four off because we won't need them, because we'll just see it on the chart. So we'll do that, do that, do that, do that. Okay, perfect. Okay, let's add a new chart here. Let's do a validation accuracy. Look at everybody. We're doing science. We're doing some science. And then we'll do validation loss. Some science here. Boom. Look at that. Look at that curve. Look at that beautiful bean. Look at that beautiful curve. I always think of Bush's Baked Beans. Look at that beautiful bean footage. Training accuracy. Just to make sure we're not overfitting. Boop. And the last chart. Training loss. And so where are you, loss? There you go. Save. Okay, so now we have all the charts we want. Now we just need to run a whole bunch of these things so that we can see all of these things compared to each other. And these things are going to stop on their own. So let's go over here. Let's delete this one. Let's go over here. Let me take that away. What do we got in the mobile net? Mobile net v3 large. Oops. Save, and we'll run this. To compare. And now I think we're cooking with gas. Uh-oh. Oh, this is the wrong one. This is the right one. That's why it's mad at me. Of course it doesn't. Here we go. Here we go. MobileNet v3 large. Remember, because we got some pretty good accuracy on some of the other models. But I was concerned about the model size because you remember a couple weeks ago, Burke was like, your model's 40 megs and you want to use it in the web? And then I got all self-conscious, friends. I'm not going to lie. I got a little self-conscious. All right. Okay, this one should be running. Let's take a look. We're going to run a whole bunch of them. Question from Jay. How big a file is a model from MobileNet v3 large? I don't remember. But we're going to learn here in a second what it is because it's going to run. I'll run 23. Okay. Oh, it's doing it. So now I can do the other one. What was the other? I can do a MobileNet v2, you know, just for kicks and giggles. And then we're going to do our ResNet flavors. The other thing I did is basically I just added a fully connected layer at the end, had the pre-trained weights in there. And so I took out extra stuff too from the model. FYI. Let's go here. We should see script 24 refresh. Cancel. Let's save the view here so we can see it. And we don't want to do show. Oh, no. We want to show all of them. Refresh. There's 24 queued up and 25 queued up. Okay. You can see run 24 is happening. I should probably output the model type early because we only output this at the end. So we have MobileNet v3 small, MobileNet v3 large, and then MobileNet. That's running. Let's get into our ResNet flavors here. ResNet 18 was the one we started with. So let's run this glorious thing. We're doing experiments. Let's make Gandalf wake up some of its other nodes. All right, Gandalf, what you got? 2 active runs. Are you gonna turn on some other stuff? Maximum number of nodes, 3. They won't mind if I do that, right? Who's paying for this? Right now, it's like, uh-oh, I gotta get to work. Okay. 26 is queued. That was the ResNet 18. Let's do a ResNet 34, I think, is the next one. ResNet 34. Windows is paying for Windows 11 is paying for it. Roshambops is right. I turn on more machines. So ResNet 34 would be run 27. All right, Gandalf, wake up, you lazy wizard. It's resizing. 3 active runs, 4 unprovisioned nodes, 1 busy node. Right now, the compute is all. You shall not pass! That's funny. Well, it was funny for me. That's all that matters. Okay. Cool. Run 27 would be the ResNet we just ran. There it is, 34. Should we do ResNet 50? Let's do a ResNet 50. ResNet 50. Let's just do it. You shall compute indeed. All right, running this one. 26 is running. 25 is running. MobileNet V3 large finished at 4 minutes 8 seconds. The parameter size is, I mean, if it large and small, you know, we're getting a 2x here, both on the model size and the param size. Look at that. 5 million parameters. 2.5 million here. 10 megabytes on this. 21, almost 23 megabytes on this model size. Where I missed, yeah, so you don't really have to do much. Like, I basically, all I had to do was say, hey, hook up to my machine learning thing, and then you set your default in Visual Studio Code. You set your default instance here like this. So I just picked it, robots, right? And so it's just, this is the, and then the last thing you do is you just have to describe the job. This is the new way of doing it. Like nobody, it's not, it's like in public preview right now, but basically you just describe the name of your experiment, your command you want to run. And this is the command we've been running locally, you know, forever. Trainer.py config. But then I just pass in different things for like where to output stuff. And then what the data directory is, right? That comes from Azure ML, right? And so yeah, I was going to show everyone. Let me do a run through of that once I get all these things running, because they're going to run for a little bit. Run 28 was the ResNet 50. Yeah, run 28. Let's do a ResNet 101. ResNet 101. And then do that. The other thing I did is I uploaded all the pictures to Azure Storage, and then I mapped. I told Azure ML, hey, this blob storage called HAL datasets, we're going to call it experiments, and then I created a data set called Roshambo that points to that actual data store, but to a specific file in that data store. So it's using the data store experiments, all the files in this folder. And so when you go to explore, basically you can see the files that are in there. And the files are, you know, it's loading a preview. Displaying the first, wow, they need to do the comma thing. So there's me. That's how it knows. So upload the data, make Visual Studio Code aware of Azure ML, write this thing that says mount this data, and use it as one of the inputs. And so then Azure ML just mounts Azure Storage as if it was a local deal. Oh, the other thing is you have to describe environments too. Like, so my environment, I create an environment that's basically PyTorch Lightning training, and I just use it. And the way you make environments on Azure ML, believe it or not, is you say, hey, I want to use this base image and then install this conda file on it, and that's my environment. This takes about 10 to 15 minutes to build because it's building a container that, an image that then gets pulled down when the experiment is about to run. All right, this is a ResNet 101. I think there was a thing called a ShuffleNet. I don't know if this works though. I don't know enough about ShuffleNets. Python minus Python trainer.py. Oh, I got a conda activate. Conda activate torch. I don't want to run on the cloud if it doesn't work. Conda activate torch. Python trainer.py config.yaml. I think this will work. I'm just going to see if it gets to the validation phase, and then I'm going to stop it. Stop. Here we go. ShuffleNet v2x1. Oh, I recently heard about the ShuffleNet. I don't know. I think it's a smaller thing. but all right, let's go back and check how everything's going in our pan over here. We're cooking up some machine learning models. Here we go. All right, so looks like run 23 is the one that's run the longest, and 23 is our MobileNet v3 small. MobileNet v2, I need to put accuracy in here because it's not. Let's do validation accuracy, max validation accuracy, because I'm having a hard time comparing. Okay. I think I need to put the loss in there too. Edit columns. I just don't want it to squeeze over. Min validation loss. Min val loss. Okay. Okay. So this one has the best loss so far. And it has 3 million parameters, 13, almost 14 megabyte file size. Let me zoom in here so you can see what I'm talking about. Yeah. And it actually ran faster, interestingly enough. These ones are going to run longer because ResNet. All right, let's see. Okay, this works. So we'll stop that. And we'll shuffle net this one up. So we'll create this resource. Create this resource and see what we got going over here. All right, how you doing, Gandalf? Oh, cancel. Let's just save this view here. And let's go to the compute. Gandalf, how you doing, my friend? Oh, it's at 4 nodes. Now we're cooking with gas. Look at that. 4 computers now running stuff for me. Thank you. They'll shut down when they have no more work. So in the interest of cost. Let's go here, Roshambo. All right, run number 30. Looks like the training accuracy all goes to 1. Looks like the validation loss is different. But we can see that here. ResNet 34 is done. Max validation accuracy 0.99. Min loss 0.018. MobileNet v2 is still better. And the parameter size differential is huge. Look at that. Oh, so that's the model size. Look at that. Did we do the ResNet 18 today? We did. It's right here. Right here. That's from Jay. DenseNet. Look at that. Let's try a DenseNet. Sorry, this is Jay. Did we do ResNet 18 today? We did. What about DenseNet? Thinking it might compress the file. Let's try it. We got ShuffleNet going. Let's see if there's a DenseNet in there. Oh, look at that. We'll go with the smallest one here. I haven't tried this one before, so let me do this. Let's see if it works. Yeah, Janiscu is telling us ResNet 18 is like half of the ResNet 34 parameter size and model size. Yeah, I mean, that makes sense because there's it feels like there's twice as many layers, right? So you would see the 2x here. You're going to see these things start to jump up super high on the other ResNets, though. It's not going to be worth it, right? We're going to look at it and be like, hey, that seems like it's too much. All right. It looks like DenseNet 121 works. So let's run this DenseNet 121. Huh. Look at that. We're doing it. We're doing it, friends. The other thing I haven't tried is a VGG. You know? Okay. Let's go back. Preparing, refresh, finalizing. Oh, ShuffleNet finished fast. Holy cow. That's tiny. That's 9 megabytes. That's 9 megabytes, right? It's smaller than MobileNet V2. There's a parameter size is equivalent. But see the loss 0.033, 0.037 with the MobileNet V3 small. I don't know. Refresh. Look at this. The ResNet 50. Holy guacamole. 102 megabytes on the size of the file. 25.5 million parameters. I had to look at the ResNet 34. It wasn't even like good. Well, it's not that it wasn't good, but I mean, luck of the draw, I guess. ShuffleNet went really fast. ResNet 50 took 8 minutes. By the way, isn't it cool that I'm running all these at the same time? Same time. We tried a DenseNet. Let's try a VGG. VGG 19. I wonder if an 11 will work. Let's try local. Because I remember I tried running this once, and I got like the convolution wasn't the right size or something. It was something like that. Here we go. Here we go. Unsupported version of PyTorch. I'm using the latest one. Here comes the sanity check. Oh, it works. Okay. I mean, I guess I don't know why I thought it wouldn't. Let's put a VGG 11 up in there. Let's see what happens. ShuffleNet. That's surprising. The loss. I mean, the training accuracy went to 1, like right away. Validation accuracy also. The loss, I don't know. Stopped improving, you know? Okay. I don't know. I think it's worth it though. I mean, this is tiny. 9 megabytes. Yeah, Jay. 0.004 difference in loss might be worth it for a smaller file. Is there a way to compare individual runs, shuffle versus mobile only? Yeah. Shuffle. Let's take that off. Shuffle versus MobileNet be small. Looks like ShuffleNet optimized itself faster. Look at that. Yeah, and that makes sense because you look at the duration. This one almost gets this is about 5. It's about 3. It is almost 2 more minutes in optimization. You know. Okay, so we just did a VGG 11. Let's do a VGG 19. VGG 19. Let's see if it works. I wonder if Gandalf is waking up another node. Let's see. Active runs 3. Current node count F3. I think it's because we stopped shooting experiments at it. It got like, I was like, I have nothing to do. I'm going to shut down. Okay. Cool. I think in this horse race, it feels like, whoa, look at the loss here already. 0.009 already? Which one is this one? This is VGG 19. Wow. Huh. Oh, I need to fix this here. Why? Oh, it's because I'm not scrolled up all the way. What's going on here? What do I got going? What do I got going on here? Let's refresh this. Why is it doing it like that? No. Interesting. I don't know why it's doing this. There it is. Yeah. I mean, some of these just, the loss goes down a lot faster. Okay, what do we got here? DenseNet 121. Yeah, this is getting comparable results to like ResNet 50. But the parameter size is huge. I'm sorry, the file size, 32 megabytes, and then almost 8 million parameters. All right, I think we're arriving at a conclusion, friends. It feels like ShuffleNet is the one to go with. You know? DenseNet. Wait, there's another one. I did a VGG 19, didn't I? Did I do a VGG 19? I guess I can start closing these things. Done. I didn't ever run the VGG 19, so let's run that here. Okay. I don't know. I think we go any higher on the dense nets, this is just going to get bigger. So what do we think, fam? What do we think? Feels like a ShuffleNet V2 X1. There's other ShuffleNets too. Let's try a different ShuffleNet. Let's see if this works. Cause I'm not sure it will even work. So let's try. Oh, geez. I had no idea I was running that. I'm sorry. Alrighty. My computer is all like super slow. Already activated torch. All right, let's see if a ShuffleNet V2 X0_5 will run. Here we go. I think we're getting some clarity though, fam. We're finally getting the clarity we need. Basically what we're doing, friends, for those that are wondering, is we're trying to figure out the model size to accuracy trade-off that we get when we run these things, right? So for example, the VGG 11 gets the best loss so far, 0.004, which is by far way better than anything else. The problem is there's 132 million parameters, and the file size is 531 megabytes. So if this was like a back end and we had a crap ton of RAM, like I would use this model. But if it's something that needs to run like agile, like on a mobile device, like imagine doing rock paper scissors against your phone. This is ridiculous. You can't have something this big. Like this is bigger than a ResNet 101. Look at that. It's bananas. Now I'm doing a ResNet VGG 19. All right, let's see if this other thing worked. Oh, this works too. Let's try this ShuffleNet. So we're going to try this ShuffleNet, which is a different ShuffleNet. We're just model shopping right now. That's all we're doing. We're model shopping. Okay. Running. And this number, the reason I know it's this number is because this is trained on ImageNet, and there's 1,000 classes. And I'm just, stealing their weights. All right, what other ShuffleNet is there? Let's go back over here. Queued up ShuffleNet number 2. And just the run time of these things, right? It's just this is what we're comparing: model size, param size, accuracy in the validation data set. Oh, what is this? Holy cow, this is tiny. What? What is this running? I thought I ran a VGG 19. This is tiny. Holy cow. It's not off on the loss either. This is tiny. This is 5 megabytes. Let me see if there's other ShuffleNets. ShuffleNet. V2X15. Let's see if this will work. Let's go here. I always like to test like the validation part, just to see if it'll run, if the images will run through the network. But so far we haven't had any. Excuse me. Oh. Can we sort on model size on that table? That's a J question. I think so. No, see, look at that. There's no pre-trained ShuffleNet as of now. Oh, yeah, and then VGG 19. Yes, sir. I guess I can pre-trained equals false and see what that does, but it's not giving us a good starting point at all. Oh, no, that's not what I wanted to do. I did the wrong thing. Control-C, 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 Control-C. I wanted to see if this would run first before I did anything. Are you done here? You're done. Are you done here? You're done. Are you done here? Nope, you're not done. Let's go back here. I ran the ShuffleNet V2 5 twice on accident. Looks like it stopped at a worse place, so this run's going to get deleted. Run 34 is garbage. Garbaggio. Yeah, it's doing it. So I don't know. We're probably not going to get good accuracy out of this because there's no pre-trained. There's no pre-trained. No pre-trained model on this one. You are done, my friend. Wow, I ran ShuffleNet twice. This one's not the best model, so we'll delete this one. No, cancel. Not all of them, goober. This one. Delete. Run 34, yes. And then the question was, can we sort these? Oh, you can't sort these. That's a bummer. I'm going to have to talk to them about that. It would be nice to sort on those things. Okay. Okay, it's a different ShuffleNet. And then we said we wanted a VGG 19. VGG 19. Oh, there's a 13 too. Well, let's do VGG 19 just to get a sense for what's going on here. This is going to be true. And boop, boop. Let's do a quick local test here to make sure it works. Make sure it works. By the way, anyone have any good weekend plans going on? The fall crispiness is happening. I guess, sorry, if you're in the northern hemisphere, the fall crispiness is happening. If you're in the southern hemisphere, you're likely going into spring, I think, which is kind of cool. Okay, this works. Oh, I didn't know if it worked, actually. Oh, I'm just gonna send it over. Winter is coming. I never watched that show. Game of Thrones. Never watched it. Okay. Here we go. Refresh here. It's running. Oof. This accuracy is terrible. So it looks like ShuffleNet V2 X05. I don't even know what that means. Let's look it up. Look at that. Oh, docs. Construct a ShuffleNet V2 with 0.5x output channels as described in ShuffleNet practical guides for efficient CNN architecture design. Let's take a look at it. We're not below reading papers. Here we go. ShuffleNet V2 practical guidelines for architecture design PDF. Has evolved over the years. I've had since milestone, AlexNet, ImageNet, blah blah, by VGG, GoogleNet, ResNet, DenseNet, ResNext, SCNet, and automatic neutral architecture search, name a few. To measure the computation complexity of floating point operations, flops, indirect metric. Yeah, see, ShuffleNet. It's basically smaller but better. Do they have an architecture diagram? This is cool. So as we're looking at this, I think we're starting to hone in on a thing. Yeah, see, this ShuffleNet has similar. This feels like the right. Oh, I passed a paragraph. Which paragraph did I pass? I was reading too fast. Practical guidelines for efficient network design. Our study is performed in two widely adopted hardware. Know that our CNN library is more efficient than most of us. Thus, we ensure that our observations and conclusions are solid. And it's GeForce GTX 1080 Ti. Wow. Which paragraph are we talking? I honestly just wanted to see what the architecture looked like. Excessive group convolution increases MAC. What is MAC? Memory access cost. Cool. That's why ShuffleNet is faster to train. Building blocks of ShuffleNet. The basic ShuffleNet unit. 1x1 gconv, channel shuffle. Oh, it shuffles the channel. 3x3 dwconv, 1x1 gconv, add with the ReLU. Depthwise convolution. Group convolution. Oh, snap. Interesting. It's convoluting over the different things that it's putting out. Oh, man, interesting. Channel split, and this is to get the residual, the vanishing gradient problem solved. Interesting. Element-wise operations are non-negligible. Conclusion discussion. Interesting. Image 224 by 224, which is what we do. Convolution 1. Max pool. Interesting. Stage 1. Stage 3. Stage 2. Stage 3. These are more convolutions, but there's no pooling. Oh, no. The staging is... It must be this thing. This is cool. All right, so let's take a look at what I think. Oh, look at that loss. Oh, this is the VGG 19. It's going to get a very good loss, but it's probably going to be ginormous. Yeah, I think the other shuffle nets we're just not going to do. Just not going to do them. Doesn't make any sense. Are there any others that I'm missing? Let's take a look. We did the dense nets. Inceptions. I mean, let's try it. I don't know if it actually works, though, on my local. All right. I think we're getting close to having our suspicions validated that we should probably use a ShuffleNet V2 X05. Although it does have the biggest loss. Oh, this accuracy is garbage. Wow, this is terrible. So what happens when you don't transfer learn, friends. That's what happens when you don't transfer learn. It just is garbage. That's garbage. Oof. This one didn't have pre-trained weights. You remember if you look here, you'll see that it has model URIs. And it doesn't have them for these two. So I'm not even going to bother with this one. ShuffleNet V2 channel shuffle. Oh, there you go. This is the actual class, the ShuffleNet class. Inverted residual and n-dot module. Look, this is the branching. Interesting. Depthwise convolution. It's a static method here. Depthwise return conv2d. Return. Oh, okay. Cool. ShuffleNet V2 is the actual class. Yeah, look at that. It's all there. I mean, cool. And this is a class that just returns a new one of these things. Okay. I think for me, it's pretty clear that we should stick with a shuffle net. Is this a tolerable? Is this a tolerable? This is tolerable, right? Tolerable. All right, let's go to the run. Let's go to the outputs and logs. Let's pull the model here, right here. There's the meta.json, and then there's the model.onyx. I wonder, let's go over here. What run is this? Run 33. Let's go here. Let's go to experiments, Roshambo, run 33. And we want to download the logs, download the outputs. And we want to download them to our AI. I think we can just do this, right? And let's go over here and see where it's putting them. There it is. Here's the output. This model is, let's look at it. Let's reveal in File Explorer. Yeah, this model is tiny. Oh, this is tiny. Let me open it up. We might be able to use this for inference. Wow, look at that architecture. I've never seen that. Oh, this is where the shuffling is happening. Interesting. This is it. I think we should totally use this. So let me take this, Control C it. And remember, we were in our API. We have this get message, but then we have the, where's the model? Yeah, I know. I'm with you, Jay. Absolutely. So let's take a look at this function. Let's close this. Didn't we write like a post image? Here it is, post image. There's the model.onyx. Let's replace it. Control V. Let me go here. Let's take this, Control C, and let's move it into our. We got about 12 minutes left, friends. Let's move it into our API. Post image. And Control V. Place. From 100 megabytes to 5 megabytes. Oh, I feel good about this. Little experimentation. VGG 19 is going to be ridiculous. Watch. Is it done? Yeah, it's done. Holy cow. The best one, by the way. Best one. 0.0008 blows everything out of the water. The model size is half a gig. Whew. I think my server soiled itself when it saw this. That's ginormous. I'm taking the shuffle net. I'm taking this one. And here's the other thing. I don't know if this is true or not, but let's go in here. Metron. Are these floats? Oh. These are float 32s. We could probably do a float 16 resize on this model and make it half that size. But I don't know how much accuracy we'd lose, though, to be quite honest. But what was that thing called on the Onyx? We could do a what's it called? I'll have to ask Cassie. She knows about this stuff a little bit better than I do. But yeah, there's the convolutions. And then here's my cheap little linear layer at the end. Scroll, 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 scroll. There it is. Right. There's the 10. Yeah, 10,000 and 1,000 to 4. I might even be able to. No, because I want these numbers, right? I want what's in here. Like these vowels are important. I was just gonna say maybe I could even just lop this off and do this. We'll save all these parameters, but I think we're already squeezing. We're squeezing so much out of this. It's just bananas. Okay, now let's get back to this. We are on the post image index context execution context function dictionary model.onyx. We did an input. So let's debug this thing. We want attached to node like this. And let's see if we can't start doing our inference on the API side with the new ShuffleNet that is a tiny 5 megabytes large. Yeah, it looks like we're done. Wow, friends, how many do we want? How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We ran 13 different transfer learn. Whoa, this one was garbage. Oh yeah, it was the ShuffleNet without any of the transfer learn values. Oh, this was not helpful. Okay. Here we go. So now we're running this. Let's see. Did we do a test thing? I think we did. Oh, I remember. But there was like some weirdness. I think I fixed it. Okay. So let's try it. Let's go to the index.thing. Hopefully this will let me run it. Send request. Nice. Let's take a look at the request object. The body is this image array. Nice, which is what we want. Okay. Now, this image array is going to have an image not in the right size, I think. Let's go over and see, because we need 224 by 224, but I don't know if that's what we're sending out. Looking at the time here. Pages, index. Use effect. Set frame. JSON.stringify. Array from. Frame.data. Set frame is passed into video device, which is going to be in components. And set frame is called. Where is set frame called? Video. Where's set frame? On click. Handle submit. Handle submit. There it is. So what we need to do is we need to change this to 224 by 224 either here or here. Thoughts? Should we change it in the API or should we just send the goods in the UI? What are your thoughts, my friends, on that? Should we set the size in the back end or the front end? Size of the image. I think it would be easier to do it here. .320 by 240. I wonder. How do we know it's 320 by 240? Oh. I wonder what happens if I do this. Let's try it. Oh, shoot. Gotta get my walk-off music here to tell me when to stop. All right, localhost 3000. Ooh. Localhost 3000. Here we go. Jay is saying, isn't it coming from the camera input? Yes. But looks like I can do this. I can force it. We can force it. Why is it not centered? Inspect. The freak, why is it doing this? That's weird. I think it's this canvas here. That's it. Let's change it. Ooh! Now we can send it exactly what we want. Let's swat this. This can go away. This one will keep. Here we go. Here we go. Here we go. We're gonna do this. Suwa. Start. HTTPS. Localhost 3000. I think it's API. HTTPS. Localhost 7071. Here we go. We can stop this thing right here. This one can go away. We're going to do 4228. 4228. Oh, 4280, Goober. 4280. 80s music! The greatest hits! Localhost 4280. 80. Oh, jeez. Well, we're almost there. We're almost there. Next time on the AI show, we're going to be talking about how to finally get inference out of a shuffle net. It's going to be glorious. I'm excited. Hopefully all of you will be there. Thanks so much for spending some time with us. Next time, more rock, paper, scissors. Thanks so much for spending some time with us, my friends. As always, it's a joy and a pleasure to be with you, to learn some new stuff from you. Thanks so much for watching, and hopefully we'll see you next time. Take care until next week. Great day.